So in this video here we are gonna look at this Armstrong 626, good old British FM and radio receiver from approximately 1973, maybe up to 76, so mid 70s. It's in for repair, it's dead, so let's have a look at it. So I have my dim bulb connected to my isolation transformer. I'm just gonna connect it here. So let's try to turn it on. So something is alive. I can see, oh, so you see the light is going on there, and it doesn't turn off. So there is probably a short or something shortening the power supply, maybe the output transistors or something in the power supply. But let's have a look at it, open it up and do the usual inspection and troubleshooting. So before we open it up, I just want to show you a little bit about this. So it's called piano dials or piano buttons. So it's a typical British slimline, almost like Bang & Olufsen Danish design. So unless the American and Japanese hi-fi FM AM receivers from the 70s, that was typically like a silver plate, bulky, big. This is a slimline with a wooden cabinet. It seems like to be in very good cosmetic condition. Not many scratches, nothing is broken as such. So it looks like it's been taken well care of. So definitely worth having a look at and try to see if we can fix it. And you see here that you got the DIN connector, the German standard for input and output, or mainly input. And you got the speaker thing as well. I think it's called DIN as well, where you got the two blades and a plug, just like you have in the B&O, Bang & Olufsen. And you got the FM antenna here, and a 300 ohms antenna input as well, and some kind of built-in antenna. I don't know if it's working or any good, but let's find out when we get it up and running. So to protect the very nice wooden cabinet here from further scratches, and so in order to protect that, I'm using the cloth here and Lazy Susan. So it seems like that these plastic tabs here, plastic screws, are what we need in order to open it. And here we go. What a nice, maybe not so nice. There is I don't know if you can see it here, but there's either some liquid here, and I think it might be some oil, or it might actually be some leakage from capacitors. Let's hope it's the capacitors, because that will help me in troubleshooting. But so far it doesn't look that bad. There's not the usual antique dust in there, so it seems like it's either been cleaned recently or it's not just not that bad. But if you just do a quick visual inspection of it, so you can see there is some liquid, and it's kind of oily, or it's not water. So I think it might be either one of those big capacitors or maybe this capacitor here leaking. You can also see that the screw here is kind of rusty, so that's probably a leaking capacitor. Other than that, the circuit boards from here looks okay. No major leakage from any of these ITT capacitors. See, there's some diodes here. So this is probably diodes here. So this is probably the power supply. We need to look at those. So let's see if we can get this cleaned up and also do a further inspection of what's going on underneath. So as you've noticed, there's a lot more capacitor fluid, I think it is, coming out of this this radio here. So to take it apart, as far as I know, there's some clips here and a screw, and then it should slide out. So let's try that. I should probably have been wearing some gloves, but I forgot to put them on. As you can see here, there is a lot more capacitor liquid here, so we have to clean that up. So this is getting a little bit messy here. Everything is covered in capacitor juice, so I'll just put on some gloves here and clean it up. So it's very obvious by now that this capacitor here is leaking a lot, and there's a lot of liquid in here coming from that one. I'll show you in a second. It also looks like the transformer here is also covered in some of the electrolytic liquid, so I might have to clean that one. Depending on if it's oil, if the fluid is oil or salt water-ish thing from the electrolytic capacitor, depending on the manufacturer and so on, it's corrosive. So you need to basically get that cleaned very well. So I think my plan for now is to basically get all the capacitor fluid cleaned out and clean everything here, so it doesn't corrode. And then of course this capacitor, probably this one and that one, will have to go. You can see there is some signs here that is already it's bulging here, and this one here I will show you is actually it's almost running out of it. So the plan is basically to get that fixed first before we'll do any other troubleshooting or even power it up, because it's either too dangerous or will probably destroy more than we will fix. So I am just gonna show you here what it looks like in a different camera angle. So as you can see here, and if you move this around here, you'll see that there's a lot of liquid down there, and it's also bulged here. So it looks like it's, I wouldn't say exploded, but it looks like that it's coming out from there, exactly like here. So that one is definitely you see now. Yeah, I just pressed it and now it's like it's squirting here. So yeah, that's definitely or it is definitely where the capacitor liquid is coming from. So yeah, it's a mess, but it is what it is. These two capacitors here, and sorry for the camera shaking a little bit here, but it's easier for me to show the close-up without having it in the trifold. the tripod, sorry. So you see these two capacitors here, this one and this one. It's not leaking yet, but it looks like there's already something going on right there. So that one definitely needs to be replaced, that one, and cleaned up there. So here you can see that this bubble I'm talking about there, you can see how leaky it is. So there's 6800 microfarad at 100 volts DC. So I've just removed these capacitors here, and I marked the wires, so I know where they go. So plus and minus, so you can see here is 4000 microfarad at 63 volt. So it's going to be 4700 probably replacing them. You can see there's a dent here. Bubble, so it's probably just a matter of time before these two will leak as well. So as you can see here, it got a capacity on 4.7 millifarad or 4700 microfarad, and an ESR on 0.6, which is actually not that bad. This one is about 900 microfarad over the value, and an ESR on 0.7, which is not bad either. They are all on value, which for me indicates that they're probably leaking. I don't have any way of testing that as such. I only have a simple ESR meter like this, and capacitance meter. So if it wasn't for the bubble, and I've seen the other one leak as it did, and it got the bubble the same place as the other ones, I probably wouldn't have changed them, to be honest, but in this case here, better safe than sorry. So I had a look at the schematics, and the two capacitors that we took out here is actually not a part of the power supply. You could be fooled to start with because they are fairly big and they're near the transformer, but they're actually the coupling capacitors for the left channel and the right channel in the amplifier. Keeping that in mind, it might not be the best capacitors that I got for that, but at least, let's get it fixed and up and running, and then if it's really bad, I can always change them to a better, a more suitable audio capacitor type later on. So I got these 4700 microfarad 63 volt. So I 3D printed a fitting, so it will basically fit in the same place as the original ones. They're a bit smaller, but they will do. So, so these ones go in like this and replace the capacitors like that. I also got a new 6800 microfarad smoothing capacitor for the power supply, and this one is in the power supply, I checked. So it was just connected with two cable ties, and just to make it fit better and not move around or anything, I just 3D printed like a small bracket here that prevented basically from moving around when I put it in with cable ties again. So let's get the capacitors in place so we can see what's going on with the amplifier. So I also said that these capacitors here was the coupling capacitors in the amplifier, and as you remember, threw it out, but remember the power supply capacitor was leaking and it felt like oily. So I did a little research on it, and it turns out that this type of capacitor here is filled with something called ethylene glycol. So it's like almost like antifreeze, and I think it's mixed with something called borax as well. So that is basically the liquid inside. The good thing is that it's not that corrosive as, for example, a saltwater solution would be. So now that we got the 3 leaking capacitors replaced, this one, and this one, there's another issue I want to address as well. So I was just poking around, and I saw that the light bulbs for the tuner dial scale, one of the light bulbs was not working, and I tried to get them out, and this spring loaded thing here, I don't know who invented that, but that was probably the worst idea ever. So basically I ended up destroying the light bulb completely. I had glass all over the place, almost cut myself if I wasn't wearing the right gloves actually. So I'm not going to replace them with a equal light bulb. Even this one is good actually. I'm gonna do more modern version with the LED diode and a resistor and potentially a diode, since it's according to the diagram is actually AC voltage. So I'll get into that later in the video and show how we can do that. But this one is not going back. This is the most annoying system ever. Another thing I identified when I was poking around was this. I was basically checking all the fuses. There's a lot of them, like 4 or 5 of them. And this fuse here is 125 milliamp. It was burnt, and before I'm hooking it up to the power and so on, I want to basically check the transistors, the diodes, the capacitors, and basically everything that's connected to this one. So this one was not the amplifier. It could have been caused by the main capacitor maybe doing some weird thing, or maybe the fluid maybe made a short somewhere. I'm not entirely sure, but you know, this one is not good, so we need to find out why. But basically what is happening here is that we have the 160 milliamp, it's 125 milliamp actually in circuit here. So that one is powering the 45 volt plus 45 volt supply. So of course I need to check the capacitors here, electrolytic transistors, these two, this one here, and there's a Zener diode here as well. So you see here that the main amplifier circuit out here is 2.5 amp fuses. So this one here is basically powering the preamp and input for tuner, disc, auxiliary, tape, and so on. So I just want to make sure that there's no short before we plug it in. So you can see this one here is blown. So this transistor here is pinned out like this, base, collector, emitter. So we can check that one first, that's the most likely culprit here. So you probably know this, but just to educate people that's new to this, or people that have an interest of what's happening. So basically what I do is I typically put one of the leads, like in this case here the negative, on base, and then check to collector, and it's open, and emitter is open. That could be good, but if we do the positive here, now there should be a diode, depending on if it is a PNP or an NPN. For fuck's sake, man. So a good thing here is to also remember to put your meter in diode mode. Just saying. So let's do it again. So we take the negative here, and we got a fairly high. This is okay. Fairly high, also okay. And if we swap them around, depending on if it's a PNP or an NPN, here we got the diode, and we got the diode reading, and checking between emitter and collector that is not short. It's not. So I will say, without taking this one out, it looks like it's okay. So the way to check diodes quickly, as you probably know, but again, if somebody's new to this or want to understand what's going on in the troubleshooting, basically the black one is the negative, and that goes to the cathode, and the red one is the positive, and it goes to the anode, and then there should be a diode across that. So zero, depending on the diode, something between 0.5 to 0.7, 0.8 for normal silicium modern diodes. If you go to germanium, the old ones is probably about 0.2 or 0.3 volt. But let's check here. So anode, sorry, the red to the anode and the black to the cathode, and maybe not the best connection here, but we see here that we got a diode about 0.5, 0.6, and if you do it with this one here, you see the same. So that's a diode. If you swap them around, there should be no connection, but because it's in circuit and I didn't lift the leg on one side, I can't really trust it, but it will be rare, not impossible, but rare that a diode will be shorted in that direction. It will typically be short or no connection. So anyway, I experience will tell me that these two are okay. If I use another meter, they'll probably be more precise. So again, anode, the red, and cathode, the black. We see here a diode. Nope. And again, a diode. And if we check it the other way around, it's about 1.5. There's so it means, for me, experience tells me that they're okay. You see the diode from the black on the cathode and the red on the anode, and you basically got your voltage drop there. Typically, as I said, 0.5 to 0.7. So that'll be okay. The Zener diode, we can check in the same way, but it's not 100% test, because the Zener diode will open up at the voltage that it's rated at, and so we need to take it out of circuit, or you need special test equipment to actually see if it's happening. So for example, a curve tracer or some of the peak Zener diode tester and so on, but you need to test it with the voltage that's higher than the voltage that is rated for, where it will lead or open up. So the normal thing you can do, and it's just an indicator that something is wrong, if it's shortened, which is the typical thing for a Zener diode that fails, or it's completely open. So we do the same thing, basically, black on cathode, and the red on anode, and we see a diode there, and should have a similar higher reading on the other way around, and we do. So I would say that all these diodes are okay. The capacitor is a different thing. So the thing you can do is that you can either take them out and then check them with either this multimeter here, or you can check them with the ESR meter I got, to see if they're actually okay for capacitance, but also if they are wouldn't say leaking because that's just a different thing, but you have an ESR, and if the ESR is very high, they might be failing as well. So I'll do that in a second. So just to be clear, I cheated a little bit like you do in the TV cooking shows. This one here I actually tested with a different voltmeter with different probes, so it's easier to get under here, and that one is okay as well. So that's the other transistor in the 45 volt power supply. So now I'm a little bit curious to, for example, if we measure from ground and see here what is the resistance, and what I'm looking for here is first of all normal ohm. So I'm looking for if there is something that indicates a short. So 3 mega ohm and 1.7 mega ohm. For me that is not a short, and that will not cause anything to pull more than 125 milliamp in circuit. So I will take the chance, and we can test the capacitors later, but I don't think there's a short. It might have been caused by the capacitors that was leaking, but I'm not entirely sure. But I'm pretty sure if I replace the fuse here, it will not blow. If I was measuring like this and I saw like a short, like something like 2 ohms or 5 ohms or 10 ohms, then I would be more concerned. So you know that it's 45 volts, so you can do the quick calculation. So of course Ohm's law, I like to put up in a triangle, and the reason for is easier is because if you want to find the resistance, which we do in this case here, you just have your hand or finger over it, and you know that you need to divide E with the current. So E, or it could be a U as well, depending on where you are in the world, and also if you're old school educated like me back in the 80s and 90s. So I use E for voltage, then you got R for resistance, ohm, and then you got I for current, as in ampere. So if you want to see what the voltage, sorry, the resistance should be or not be higher than or lower than, in this case here, we know we have 45 volts. And we have 0.125 amp. So if we do a quick calculation, which I will do on my phone here, 1 second. So that will give us 360 ohms. So I will say that in this case here, if the resistance that we are measuring is higher than 360 ohms, the fuse will not blow, and I think we are all good. Another thing I have decided to also get rid of and replace with some newer ones is these wire protector or sleeves here. So I don't know if it was because of the electrolytic capacitance fluids flowing into this, but they're quite sticky and annoying. Or maybe it's just the way they were produced or became over the years. So this one here I will at some point also replace. So let's replace the... So as you can see, it's rated at 125 milliamp and is fast blow. So I got a replacement for that. So let's pop that in. Like that. So let's power it up on the dim bulb just to be sure, because as you saw when I started this video here, there was a short in the beginning. I wasn't really sure if it was a short or not, but I think it was because of the capacitors. So let's do the dim bulb thing just to be sure, and then we can always look at the isolation transformer and see how much power and voltage and so on is drawing. So let's set that up. So just to explain the setup here, I have my isolation transformer up here. It's going through additional fast flow fuse here, going to here via this connection. The dim bulb is going to here, and then the amplifier receiver, the Armstrong, is going to the dim bulb. So we have isolation, we can see how much power is drawing here, and we'll be able to see if it's short here as well and protect the circuit, and we can also keep an eye on if this one here will blow. So I would say let's power it up and see if we're lucky. So isolation transformer up and running. Light bulb, there's no power on at the moment. Turning on the light bulb. Still good, no short so far. And we now turn on the power. And the good thing is that, I don't know if you saw it, but it only lighted up like very short and not very bright, not like when we tested it the first time. We can see here on the isolation transformer that we are drawing about 20 watt, about 100 milliamp, which is okay for it in standby. And so far the fuse we replaced did not blow, and no smoke, no noise, no nothing. So I feel lucky. Let's check if there's any voltage on the speaker output. There shouldn't be there, like the bias and so on. And then we will hook it up to some loudspeakers and see if it actually works or not, or there is more to fix. So I have hooked it up to the isolation transformer, removed the dim bulb because we don't need it anymore, and just to show you that if we power it up now, you see there is a light in the 2 meters here. Of course we don't have any light in the tuner dial because I removed the light bulb, and I can tell you annoyingly still there's coming glass pieces out of the radio. So as I said, that spring thing that is keeping the light bulbs in place is really annoying and not aging well. So let's test the output from the speakers to see if we have any high voltage or anything that could potentially destroy my speakers. So just having a quick look here on the back plate, and you'll see here that the one on the right is speaker set 2, left right, and the one on the left is speaker set 1, left right. So that will be on the board here, there will be speaker set 2 and speaker set 1. So we have a pretty high bias on this output of the speakers. It's about 200 millivolt. It's a little high, to be honest. I don't think it will damage anything, but it might be worth actually checking the output amplifier before I connect anything. So I have hooked up the amplifier or receiver with an aux auxiliary signal here, and I hooked it up to some loudspeakers as well. And I have my signal generator here, good old trusted TTI. So I got 600 Hertz at about 120 millivolt into the aux input, and I connected it to some speakers, and I just one over there as well. So left and right speaker. So we got sound, which is a good thing. Let's check the balance first. It's working in the right channel. And here you will see that the left channel is not working for the balance. And the treble. Doesn't seem to be any problems as such. When I was testing it before, there was some scratching and noise from the volume, and some scratching and noise from the balance as well, so that looks like a clean. So before I start troubleshooting and take it apart and change components and what have we, I think it would be a good idea to clean all the contacts and all the potentiometers, because that is a likely reason for why the balance might not work, and also why there's some noise when you're operating the volume and the balance. So let's do a good old cleaning of the contacts and potentiometers. So I am using contact chemie, so I'm not the American, I'm not raised with the American products, I want to say. So the oxide and so on is probably very good and so on, but since the 80s I've been using contact chemie, which is I think it's a German brand or something like that. At least this is what we kind of grew up with in Europe, where I'm from. So this one here I'm typically using for potentiometers. So it's not Feta grease, but it's like good for potentiometers. General contact cleaning and cleaning potentiometers to start with, I'm using this W40 contact cleaner. It's important that you're not using W40 as in the lubricant, but use this contact cleaner for your potentiometers. So this one are my go-to products for fixing electronics. And also don't forget the phono output, the headphones output. There's a contact in here that is activated by the jack plug, and they tend to sometimes have a bad connection. So now that we have cleaned the switches, the potentiometers, the contacts and whatever, we have our tone again, and the balance is now working. And I tested it on different speakers here, and it works on both on speaker set 1 and speaker set 2. Right now it's speaker set 2 connected. So what we have left to do is change the sticky wire protection at the phono section, and we need to do the lamps.